All right, so let's see if we can graph this function by itself. Let's answer a few questions here. What is the amplitude of this function? The coefficient outside is 1, so the amplitude technically is the absolute value of 1, which is 1. And what is the period? Well, the period is, we take the period of the basic function. We know the basic function is sine. We know its period is 2 pi. But you divide by the coefficient inside. Now notice, I've written this up here. 1/2 times x is the same thing as x over 2. So no matter which way it's presented, it's the same notion. Sometimes students get confused. They think those are different notions. X over 2 is the same thing as 1/2 times x. So even if it's x over 2, the coefficient is still 1/2. So take the basic period, divide by the coefficient. To divide by a fraction means you multiply by the reciprocal. So this is 2 times 2 pi is 4 pi. So this amplitude is 1 and the period is 4 pi. So how are we going to draw that? Well, the really long horizontal x-axis, this is still -1 to 1. This is still approximately 1, 2, 3, approximately 3 units is pi. So count out about 3 and maybe a little bit more. That's pi, but we need to go all the way out to 4 pi. So 1, 2, 3, 4. So just approximate that's good enough for our graph here. So the period, this goes through one complete cycle between 0 and 4 pi. Now, we know what happens with the sine. The basic shape sine curve. Sine, the basic shape curve, we know the basic curve. Right? Isn't that a rough sketch of what the basic sine curve looks like? Starts at the node, goes to peak, goes to node, goes to trough, goes to node. And so here's what we do. We take the entire period, find the period first, and we need to divide this so we can find these basic points. Notice what we did here. In the basic, this is 2 pi. You divide this into 4 equal pieces. So you divide this into 4 equal pieces. That's not very challenging. The largest value is 4 pi. I need to divide this into 4 equal pieces. The first fourth, it goes up to the peak. The next fourth, it comes down to the axis, the node. The next fourth, it goes to the trough. And the last fourth, it comes up to the node again. So we start, in this case, the fourths are 2 pi, pi, 3 pi, 4 pi, and 0. So this almost divides itself. Starts at, so now sketch in the basic points. Starts at the node, goes to the peak in the first fourth, then goes back to the node. The next fourth goes to the trough. The next fourth goes back to the node. And so this is a much longer, stretched out sine curve. If we were to draw, now you don't need to, but if we were to draw the ordinary function, suppose I draw g of x is just the basic sine curve on this same axis. I'll draw this in red. If we were to draw the basic sine curve, we would start at 0 and use what we've done all along. This is pi over 2, pi, 3 pi over 2. We would start at node, peak, node, trough, node, and this would be the graph. And so you see what's happened. When you multiply by 1/2, it actually stretches it by a factor of 2. If the multiplier is less than 1, between 0 and 1, if this multiplier is between 0 and 1, then it stretches this graph longer. It turns out if the multiplier is larger than 1, then it contracts the graph.